Hey everyone, thanks for joining. We're just going to give it a couple more minutes, get to the top of the hour and let folks filter in. So we'll get started here shortly. Hey all, thanks for joining. If you're just joining us, we're going to give it a couple more minutes to let folks filter in here at the top of the hour, and then we'll jump in to the topic in a minute or two here. All right, let's go ahead and get started here. We'll let others trickle in over the next minute or two as we get started here. Let me go ahead and kick things off and introduce myself. My name is Andy Gower. I'm a Solutions Marketing Manager here at Portworx, and I'm excited to be joined today by Ryan Wallner, who is our Technical Marketing Manager Extraordinaire. And today we're going to talk about security. I know security is top of mind. It's something that everyone has a heightened sense of awareness of with things we hear in the news every day, with things we talk about in the tech world every day. And specifically, we're going to talk about what we're doing with Pxstore on Red Hat OpenShift. Now, this is a very exciting topic, and it's a little teaser for some things we've been working on here at Portworx. Ryan has been really helping to do a deep dive on Red Hat OpenShift, and we're going to have a lot more on that coming out over the next few weeks. And stay tuned, be on the lookout for some of that. But today, this Pxstore use case is a really great one to jump into and talk about. In terms of roadmap for today, if you've joined us before, you know the first 10 or 15 minutes, I'm going to talk about the platform as a whole, so that if you haven't joined us, if you're new to Portworx, you can hear what we're doing at a big level, at a macro level. And then I'm going to turn it to Ryan to deep dive on Pxstore, show a demo, show what we're doing with Pxstore on Red Hat OpenShift. Of course, throughout the presentation, please feel free to ask questions in the chat. We'll leave time at the end for Q&A as well. And please, make this an interactive session, so feel free to join in throughout the conversation. So with that, I'm going to jump right into the platform as a whole and kind of what Portworx is doing in the market. And it really starts with data. I think everyone on the call, everyone in the industry knows that data is really the thing that's powering businesses forward into this new business of tomorrow, into this new business landscape. And it's something that's really accelerated with COVID as we've moved from analog storefronts to digital storefronts, really having to be the center of all business, the driver of all business. So as this data grows, the leaders, the winners in this space are those who are using a cloud native stack or using a new approach to harness and process that data into value and insights that can actually be used for the business, that can be leveraged by the business to turn data into success for their customers, into business ideas and products for their customers. And that cloud native stack starts with a multi-cloud infrastructure. It's driven by app-driven automation on top of that with Kubernetes and containers. And on top is a set of new, largely open source data apps and data services that are helping companies break monolithic applications into microservices and really take advantage of this new cloud native stack. And by extension, we're seeing new people and processes come to light because of this adoption of the cloud native stack. Things like DevOps, things like GitOps, things like the site reliability engineer, all new people and processes that are really driving this cloud native stack forward. And containers and Kubernetes is really what is taking this to the next level. So what we see, what the research shows is that 95% of new applications are being developed in containers. 81% of enterprises are working with 2 or more public cloud providers. 78% of CNCF members are using Kubernetes in production. And 85% of global businesses will be running containers in production by 2025, up from 35% in 2019. So containers and Kubernetes is really what's powering this new cloud native stack. It's what's driving the stack forward. But what has also become clear is that storage starts to run awry as this cloud native stack scales. So if you are using your traditional enterprise storage that was built for a virtual machine world, that was built for a time before containers and Kubernetes, it doesn't quite have the language. It doesn't speak Kubernetes, it doesn't speak namespaces, it doesn't speak the type of services you need to support a cloud native deployment. Things like, how do I easily move between clouds? Things like, how do I protect sensitive user data? How do I deliver performance within the SLAs that are required? How do I ensure that there's cross availability zone DR for my mission critical applications? How do I have backup and recovery? What about role-based access and control? What about compliance and governance? These are all things that you have to have in place to have production workloads. And that is true whether you're running in a traditional environment or this new cloud native environment. And so solving these problems is core to being able to move from testing Kubernetes and containers to production with Kubernetes and containers. And that's what Portworx is set out to do. Portworx delivers that modern data experience that cloud native apps requires. It provides the foundation for taking cloud native apps and putting them in production at scale in your Kubernetes environment. Now, for those of you who don't know us, who haven't interacted with us before, we are the leader in this space, both in the cloud native storage space, which you see on the left, and the enterprise Kubernetes storage space on the right. We were named by GigaOM earlier this year as the gold standard for Kubernetes storage. And we also work with a wide variety of enterprises. So you see on here a lot of different industries, a lot of different partners. And we put this slide up here to say, we are experts in this space. We have worked with a lot of companies in a lot of different spaces, a lot of different verticals to solve their problems with containers and Kubernetes. So if you have a problem, we've likely seen it before, and we've put together some best practices. We've integrated it into our solutions. We've helped really drive success with containers and Kubernetes deployments with some of the biggest companies in the world. And we can do that with your companies as well. Now, when we talk about Portworx as a whole, it really is that single platform that lets you build, automate, and put cloud native applications into production at scale in a secure way. And we support any Kubernetes distribution with any app running on top. So open source databases like Cassandra and Couchbase, streaming apps like Kafka, AI, ML like TensorFlow, any app you're running on top. We support any cloud, any infrastructure, both pure infrastructure, VMware, bare metal, Dell, EMC, HP, IBM, whatever the case, we support the infrastructure. And most importantly, we support it at every stage of the application lifecycle. So from the time you come up with the application on a whiteboard, to the time you actually test it, to the time you go live with it, to the time you scale it around the globe. Portworx is that consistent Kubernetes data services platform that you can use throughout every stage to support those applications at scale. Now, what is it specifically that we're doing? So Portworx is broken up into 6 core modules. So I'll start from the left here with Pxstore. Pxstore is that software-defined storage layer that automates container storage and provides the container-native persistent storage you need for your applications. The next one we have here is Migrate. Migrate is really focused on how do I move my application between clusters for hybrid and multi-cloud availability? And how do I make sure I'm moving the entire application? So not just the application data, but the Kubernetes objects, the app details, the app, maybe it's on multiple namespaces. How do I make sure I'm moving that application the way I want to move it with the granularity that I want to eliminate lock-in, to maintain control, to easily move things around as I see fit. PX Secure, that's the topic for today. I won't go into too much detail there. I'll leave that for Ryan to uncover here in a couple minutes. PXDR is focused on how do I ensure high availability replication, both synchronous and asynchronous, between availability zones, between regions, between clouds, so I can eliminate downtime and have 0 RPO for my Kubernetes deployment. PX Autopilot is focused on how do I scale in a sensible way? How do I optimize my scale? So rather than over provisioning cloud storage, how do I make sure that I'm only provisioning what I need when I need it? So rather than spending too much money, I'm spending the right amount of money. I'm saving on my storage costs. And last but not least is PX Backup. And PX Backup is available both as a standalone and as part of the broader platform. And it's focused on what it says. So backup and restore. And specifically, it was built from the ground up for containers in Kubernetes. So it talks the container and Kubernetes language. So it backs up at the namespace level. It backs up at the container granular level. It is app aware. And it backs up not only the application data, but as with PX Migrate, it also backs up the Kubernetes objects and any other metadata associated with the application. So you get a true backup and a true quick and easy restore with PX Backup. And as I said on the previous slide, these 6 modules go across any Kubernetes distribution, running any app on any cloud with any infrastructure and at every stage of your application's journey. Now, before I turn it over to Ryan, I do want to talk very quickly about 4 places where we have taken Portworx into the field and seen success with our customers in a number of different use cases. So the first one here is speed with T-Mobile. So when T-Mobile came to us, they had really 2 problems they were trying to juggle. The first was when a new iPhone was announced, as it was announced last week, they saw a huge and sudden surge in demand on their website, traffic that would spike up and then it would come back down as the tail from the Apple announcement went away. Handling that spike was a challenge. Making sure that they had the infrastructure in place to handle that spike was something they needed. At the same time, they also were trying to figure out how do we reduce our app development time, which at the start was 6 months, down to hours. So if Apple announces a new iPhone with a specific feature, we can quickly roll out a new marketing campaign the same day or the next day. So we don't lose in the marketplace. We have the speed we need to compete in the marketplace. And that's something that we were able to partner with T-Mobile to help them deliver. The next one here is Roblox. So Roblox is a really interesting one. Roblox is a big gaming company. For those of you who haven't interacted with them, they have something like 70, 75 million users. And at the beginning of the pandemic in March of 2020, they scaled as much in 1 week as they had in the previous year combined. So think about that. You have generational shift in your scale from in 1 week. How do you manage that? How do you have the agility to manage that from a store and data management perspective? Well, partnering with Portworx, we were able to provide the platform Roblox needed to be able to handle that scale and continue scaling as more and more users join their platform every single day. The next one is reliability. So RBC is a great example. They're a big bank in Canada, and they've moved a lot of their applications to Kubernetes, but they reached a specific banking app where having 0 RPO was critical. They had to know it had 0 RPO to move it into Kubernetes in production because it was that important to the business. And so they came to us and said, hey, can you provide us a solution to ensure that we have the reliability we need for this application? And working together with them, we put together a disaster recovery support for them where they had 0 RPO between independent data centers, and they were able to safely and reliably move that application into production on Kubernetes with Portworx on the back end. And then last but not least is cost savings. So this ties right into the PX Autopilot we talked about on the previous slide. This is Audi Business Innovation, and they came in and they were looking for speed, they were looking for agility, they were looking for reliability, and they got all those, but they also got cost savings. And working with us, we were able to cut their AWS storage bill by 60%. So they stopped over provisioning their cloud storage, and they also gained the speed, agility, and reliability they were looking for in their applications. So with that, these are 4 really good examples of how we have helped companies really accelerate their digital transformation, really find some of those key things they're looking for in their move to containers and Kubernetes. You know, hopefully we'll whet your interest throughout the rest of this presentation. I've you know, got you interested so far. If you are interested in our trials, we have 3 trials: the Portworx Essentials Forever free version, the Portworx Enterprise 30-day free trial, and the PX Backup 30-day free trial, all available at the link here. So please check those out if you're interested. And we also have a number of resources that are OpenShift specific. So while Ryan is talking specifically today about PX Secure, we also have a number of other OpenShift blogs that have been put out there at this link, portworx.com/OpenShift. You can hear about things like migration from OCP3 to OCP4, and how to do backup and restore with OpenShift, and that will be the home of the additional technical deep dives you'll see coming out in the next few weeks from us. So with that, I hope that I've piqued your interest enough to check some of those resources out. In the meantime, Ryan, let me turn it over to you to talk about PX Security and OpenShift.
Yeah, I'll just take over the screen since I'm going to have to demo anyway. So let's just do that. Thank you very much. All right. All right, I think we're good to go here. I'm seeing both of my screens, I think. Let's just do screen 2. There we go. Okay, so PX Security on OpenShift. We're gonna focus in on the PX Secure component that Andy talked about earlier. PX Secure is made up of a number of different things. So typically we talk about authentication, authorization, ownership, and encryption of Portworx volumes. I'm going to add security auditing because while it's great to have these features, you know, knowing when these things are being challenged or compromised or, you know, effectively used, auditing is a great way to do this. So we're going to cover that today. And these are sort of the broad range of topics which I'm going to cover briefly, and then hopefully showcase a number of these live in a OpenShift environment. And please, I did put in the chat that feel free to put your questions in there. We have sort of an intimate group here today. So if I do see questions, I'll try to answer them live. If I miss them, I will come back to them at the end. So, so definitely take that opportunity. The first one I'm going to talk about is encryption. So Portworx provides encryption at the sort of Linux kernel and DM encrypt level. It does so by integrating the bind mounts of the volume with the device mapper devices integrated with the Portworx data path, which uses keys to encrypt and decrypt the data to the actual application volume itself. So we'll talk a little bit more about key management in just a minute, but encryption is a key and critical component of your Portworx security component, allowing you to sort of encrypt data at rest. Key management, these keys are used to encrypt these volumes as well. So Portworx can use various key management systems like Vault and IBM Key Protect or AWS KMS. Users create these, and a user in this perspective can be a Kubernetes user or a Kubernetes system. As you'll see later in the demo, what I'll actually be showing is the Kubernetes storage classes that contain some of this information that are created by Kubernetes admins or OpenShift admins, and those keys are made available within tenant or user namespaces. And so the user references that key through a PVC definition or a storage class definition, which Portworx then understands how to communicate securely with that key management system, such as Vault or AWS KMS, to retrieve the key to do the encryption and decryption of that volume. Now, Kubernetes secrets can be used outright. So if you don't want to use an external key management system or you don't have one, Kubernetes secrets can be used. So within OpenShift itself, that can be one way to do that. Those keys get passed to the Portworx encryption system in the Linux kernel using dencrypt to encrypt and decrypt those devices. Another key component that we're going to talk about today is how to allow your tenants or multiple users access your data in a self-service and trusted model. So often OpenShift clusters have many projects, and those many projects may have a number of different user or application teams associated with them. So a single project may want to deploy a number of stateful services, and they may want to encrypt those services at a granular level, meaning that having encryption at a pool level or a cluster level is great from sort of compliance perspective, but at the same time, if you have a multi-tenant model, you may want to encrypt each individual PVC or data service with its own key. And Portworx does enable this. We call this per PVC volume encryption, allowing users to self-service their own encryption keys for their OpenShift stateful services. And so we're going to showcase a little bit how that sort of differs from cluster-wide and sort of the benefits. Now, of course, if each team has their own Kubernetes cluster, this may not be a model that you would use, but often Kubernetes clusters are shared across OpenShift projects. The other component of this is the sort of token-based authentication that Pxstore brings to the table. So we're going to talk about the role-based access control model that Portworx integrates with. The OpenID Connect sort of standard. We have integrations with LDAP through that, so you can import your users from your enterprise and map them to different groups and different roles within Portworx. Now, it's key to understand that the role-based access control that Portworx Pxstore brings to the table is different than the Kubernetes role-based access controls. And this can be viewed as an added layer of security for your Kubernetes environments, meaning that you have cluster-focused security and then you have a data-focused security. Portworx has its own role-based access controls so that when you map users within the OpenShift system to your backups, targets or your Portworx enterprise volumes targets, that those roles and users are specifically tailored and authorized to interact with the data, such as creating volumes or snapshotting them, deleting volumes, and those systems. Now, the roles within that role-based access control model, Portworx ships with a bunch of defaults. So there's system admin, view, and user. There's actually a system.guest we're going to talk about that's not on the slide. Clearly I need to update it. But system.guest is effectively a way for you to enable security, but still allow sort of guest access so that while you are ramping up your Pxstore model, you're not sort of blocking everything. Some have preferred that. Users can administer volumes, create their own within a tenant namespace, whereas system.view is pretty much a read-only call. And system admin is a full sort of admin rights. And all of these roles are integrated with the API. So if you're interacting with Portworx in sort of an automated fashion through the SDK, you can define your own custom roles, which is important. That the ones that are shipped are immutable. You can't change them, but you can create custom roles for your needs that interact with the Portworx and data APIs on a very specific manner. The last is the ownership portion of this, and this is where sort of the users groups and collaborators get and sort of ownership of particular resources like volumes or backups can get mapped to various volumes. So you may have a user that owns a volume and allows multiple groups to also partake in viewing that volume or copying that volume, right? So a user from a different group can clone that volume into their own OpenShift project, but they can't necessarily modify the original volume. And these are important when you're talking about collaborative users and multi-tenancy models within OpenShift itself. The last bit I will show is auditing. Security auditing is a big portion of this. So all of the RBAC controls that I mentioned that are specific to the Portworx data model can be audited, and we'll show how to sort of tie that into Elasticsearch and Kibana to visualize it and see what's going on. They are available on every Portworx node. At those paths, there's actually an open storage audit log and an open storage access log, and those are vital to sort of seeing what's going on, seeing what volumes may be trying to be accessed by users that may not know or are trying to maliciously access a volume or some of your data. All right, let's stop sharing here. And so the first thing I want to actually, before I drop into the actual terminal and UIs, in our documentation, if you head over to concepts/authorization, there's a role-based access overview, which is an overview of a lot of the concepts I talked about today, but in a little more detail in terms of what exact terminology we use, what's a token, how you can use JSON web tokens and tools to validate, the tokens you may be working with and using. There's a couple different methods today of using those tokens, such as self-generated or using an Open ID Connect sort of tool, such as Keycloak or Okta. A lot of those are used today. So definitely go check this out. A large portion of the security documentation is around how to actually configure it. So if you're running Portworx today, or if you're installing Portworx, there's a couple different ways to enable security. You can enable security from the start, or if you're already running Portworx Enterprise, you can drop into your existing installation within your OpenShift setup and enable security within the storage cluster itself. And actually, why don't I show that real quick? So I have an OpenShift cluster here. Let's quickly log in and I'll show you how security is enabled. So within your administrative view here, if we go down to operators and installed operators, the Portworx Enterprise operator is installed, and we do have a single single Portworx cluster installed and online. Now, within this installation, if you head over to central.portworx.com, this gives you the ability to produce a spec file to install into your OpenShift cluster. And towards the end of this, right, you can choose the operator. You can move through all of these sort of different components, but I want to get to the point. If you're running OpenShift here, 4+ for sure, definitely click on this. But then there's a security section setting, and it is not enabled by default. But if you are looking to run security from the start, you would go ahead and select this authorization to enable PX security. And within the actual YAML file, which I'm showing right now, there will be a security section. So here it is: security, auth, guest access, some issuer shared secrets, token lifetime defaults, whether it's enabled. So by default, you have to enable security, right? So you enable this to true. And then from here, the guest access is not managed by default. I will show you what that actually means. So for instance, if you install Portworx and enable Px Security, the guest role that we talked about before enables guests to your OpenShift cluster to still be able to provision, a PVC and things like that. Now you can disable guest access, or you can manage guest access. And then you can actually create a custom version of that guest access. So let's go take a look at what that actually looks like. But by default, these are the things you need to enable security. Portworx will go through a rolling update to basically configure itself for security. And then your OpenShift cluster and Portworx are enabled and running for security there. So let's head into our cluster here, and let's log in. Let's see, login-u, kubeadmin. Got my password here. So the guest access is managed within Portworx itself. So if you have access to your Portworx nodes, you can go directly there, or you can enter the Portworx pod in the way that I'm doing here by grabbing the pod name and execing into that pod. I'm going to create a quick alias to the Portworx CLI. And in here, I have a file called guest managed. And so this is a JSON file. But really, on the Portworx documentation, we gave you the default of what the managed role is, meaning that if you want to change it, we give you what it is, so you can always revert back to it, and you can modify it. So if I remember correctly, the guest role pretty much is exactly what you're seeing here. So it's saying that any guests can have access to volumes, cloud backups, migrations from within a Portworx context. But by default, it allows you to do anything with those. So basically, guest access gives you the ability to sort of enable security, but not change anything right away, right? So this is a really good use case if you're running running Portworx already and you want to enable security, but you want to enable it and not break everything from the start, right? You may go through some testing phases to see what kind of roles or user profiles work for you, and this is a way for kind of customers to do that. But when you're ready to start limiting it, you can go to a managed guest role and start doing things like this line says, don't let them create these things. So they can view volumes, they can view cloud backups, they can view migrations, but they cannot create them. And you can extrapolate there from essentially allowing them to see other things such as identities or Portworx cluster views or node views. You can limit them on being able to do things like just inspect them or just list them, enumerate them. So the guest access role and the custom role is very powerful. So creating a custom role within Portworx role-based access control is very similar. You would basically create a JSON file like this, name it something else besides system.guest, system.foo, or whatever you want to call it, system.devops or system.dbops or something, and create that role that you can then use within your user profiles. So that's what that looks like. And you may be asking, okay, so how is this then used within a Kubernetes context? There is the idea of an auth config. And this auth config is, I have a few here. Let's see. Oops. I got kicked out of my cluster. That's why. Nothing like a live demo. Do we have any questions, Andy? I haven't looked, so I'm gonna lean on you.
None in the chat so far, but yeah, if folks have questions, please drop those in the chat as we go through here.
So I'm going to show you what an auth config looks like for a user. This is an example YAML file of defining a user. Now, this user definition could come from a location like Okta or another OIDC provider, but we're kind of laying it out in a file format here just because we have some local tools that we can define these things. But you would often find these definitions of who's a user, what roles and groups they belong to within those type of systems. But in here, you'd have some basic information like the name of the user, what's the sub and email, what roles they are. In this case, I'm using the default system.user role, and this user belongs to no groups. But if I wanted to say, edit this file and say this user belongs to system.devops, because I know it exists in my organization, that can be the case. Now, you can also create tokens based on these users, and often systems like Okta or other OIDC providers provide a token generation, sort of a token authority. Now, Portworx ships with a default way of doing this, which is self-signed tokens. And so we enable you to generate tokens directly from the Portworx CLI as a token authority. So the way that this would be used is through running the command pxctl auth token generate, and then you'd pass an auth config and an issuer and the shared secret, and out spits a token. Now, I believe if you just take this to jwt.io, you can plop this into this token here and get a whole bunch of information on the user. So you can see that these are standard JWT tokens which encode the user, expiration, what groups they belong to, the role it is, and the sub. So this type of information is something that you would also find in something like Okta or Keycloak or other OIDC providers, and you can map those in as your OIDC provider to Portworx. But again, I'm using generated, self-signed, so you can produce these locally from the Portworx for this demo environment. And then from a user perspective, right, you can create context within Pxctl itself. So if I do context list, you'll see a bunch of different contexts here that I've pre-created as an admin, and you can do a Pxctl set or context set admin, and now I'm an admin and can list my volumes in this cluster. Now, normally as a user, you wouldn't necessarily be interacting with the Portworx system itself, right? We're using Openshift. So how do users within a Openshift environment start using security? So as an admin, I would have some authority to produce tokens. So I'd probably, as a Kubernetes admin or Portworx admin, have access to my token authority and understand the users, and users can provision those. I can provision tokens for tenants within my system. And the way that a Kubernetes admin would enable users to do this, let's go in here. A standard PVC would look something like, we're going to use a not secure example here. A standard PVC would look something like this, right? We have a PVC name, we have a storage class, everything looks normal, right? We can kind of agree on that. So let's go ahead and let's try to create this, right? So I'm logged in as an admin, but for this use case, we're just going to create this PVC. So PVC001 created. If I head into my storage use case here, go to PVCs. Oops, I'm in the, there we go, default. PVC001 is pending. So when PX Security is enabled and you're using a managed guest service, as a tenant or as a user of this OpenShift project, the default project, I've tried to create a PVC, but I haven't authenticated myself in any way. And I definitely haven't authorized myself in any way. I've authenticated with the OpenShift user interface and the OpenShift CLI, but from a data perspective, I also need to verify that, hey, I'm allowed to create PVCs. So by default, the system will, the Portworx system, when it's secure, will deny you access to creating volumes. Now, this is actually the expected behavior, right? I don't want any user within my system, say OpenShift gets compromised from that perspective, to create terabytes and terabytes of data, or within my system. So data security wise, it can't consume all my resources, and we're gonna get notified that someone's trying to create and getting denied access. So how would you then enable a user to be authenticated, right? So now I have the idea of, do I want to enable users to create volumes as a cluster-wide component of authorizing? So do I want to enable this Kubernetes cluster to be an authorized user to create volumes, meaning that any user within this namespace, within this OpenShift cluster can create volumes? Or do I want to do it from a tenant perspective? I'll show you the first one, which is as an admin, I would create storage classes, right, for my tenants to use. If this is sort of a shared model, or even if your organization does have Kubernetes admins that set up storage classes for your users, that's pretty common. They would actually provide a couple of different flags within a Portworx storage class, which is a secure equals true, which basically says make sure this volume is encrypted. So step one, we want all volumes to be encrypted so it's secure. And then secondly, they would map in tokens. So in this case, I'm mapping in a single token as an admin that I have access to, which gives whatever user has access to the storage class the ability to create volumes. Now, if I create a volume from this storage class, we'll create the storage class first, and then a PVC from that. We should see now in our volumes that we now have a created volume with no problem. Now, what Portworx has done here is basically it has a secret that I've pre-created in the kube system namespace. And within that kube system namespace, that secret is called PX user token, which has a valid JWT self-signed token in this case to authorize the users within this Kubernetes clusters to create volumes. Now, this is great because it still only allows users within this cluster to create volumes if they're a known user with access to this namespace. But what it doesn't, and this keeps people from the outside or attackers from the outside from trying to sort of authorize themselves to spoof a token to try to gain access to your system or something like that. What this doesn't really do is give you the ability to limit based on sort of the tenant, and we'll drop into that. But quickly, let's go take a look at that volume we just created, and we can use the Pxi tool to do that. I believe this was persistent volume. Oh, here we go. We need this name. If we do a quick look at this, we can see that this volume is up and detached, meaning we've created the volume and it's not being used, it's encrypted. That's what this means. And so we've succeeded in creating that as an authorized user. So now as a multi-tenant use case, you may be wondering, right, what this looks like. So now I have I have two different tenants. Let's call them analytics and DBOps. So in my authorization model, I have a DBOps profile, which is a user, and they are part of the users group. And then I have an analytics group here that are basically also a user. But now within Kubernetes itself, right, I can log in as as this same user. So let's see, login -u dbops. And now I have access to let's see, get pods in the dbops namespace, but I do not have access to the analytics namespace. Or sorry, I have read-only access in the analytics namespace, but I do not have anything more. So if I try to go ahead and create, let's say create a PVC in that namespace. Let's just do that example. Let's say analytics, right? This is Kubernetes RBAC saying that I'm a DBOps user, but I cannot create persistent volumes in the analytics namespace. And so what we can do from a Portworx perspective is create a profile for the DBOps user, the same way we've sort of done in Kubernetes, and give them their own token, right? So now we're distinguishing between who is DBOps tenant and who is analytics tenant, and giving them different roles. Even though in this example they both have system.user, you can define custom roles for analytics versus DBOps, because you could imagine DBOps, could run things like DB2 for another team, where analytics could clone and those kind of things. So you're distinguishing between tenants now. So now at this point, what we can see is that we have our own tokens, and as an admin, those tokens are now available within this namespace. So as a DBOps user, I can view my user token within my namespace. So I can get this token, and just like before, I can, well, this is encoded, but you can decode that and put it into JWT and see that, yes, this is all my information. Now you'd want to limit who has access to these secrets, right, across namespaces if you are in this multi-tenant model. But now what I can do is provide a specific database storage class for DBOps, meaning that my auth token is within my namespace. And with CSI, you can actually do this even a little more securely. You can have a single name storage class which calls out, which maps in what namespace you are and what PVC. On our documentation, it shows how to do this, but you're also able to do this without CSI. So keep in mind, this works in both cases. And you can map that user token in. And so at this point, from the DBOps perspective, I have a DB2 storage class that's mapped to DBOps, and as an admin, I can show that specific volumes now have ownership models to them. Oops, let me log out. Nope, that didn't work. Never mind. So specific volumes have ownership to a volume, and so you can understand that a specific volume in the model we explained before is owned by DBOps now, and that DBOps person and team can add collaborators and those kind of things from that perspective. But if I were to try and say be the analytics team and inspect one of these DBOps volumes. So I have the analytics token here that is in Kubernetes, and we can try to map out. Let's log out real quick. We can say volume delete, but pass in the analytics token, and looks like my Pxi utility is not working for me right now, but effectively you would get denied this access here for that particular volume. Now we showed a little bit about how encryption works. Encryption is done at a cluster-wide or a PVC level, meaning that if you were to look at the volumes within, that's why, there we go. this is security at work, even to the person who set it up. So I was logged in as the admin, the DBOps user, and I couldn't perform certain tasks, which is exactly sort of what we expect. So that's my own fault there. So let's go ahead and log in and show you what I was trying to show before, which is this access show. See, so what I'm doing now is volume access show to that DB2 volume, and so we can see it's owned by the DBOps team now at this point. And if I tried to delete the volume from a analytics user perspective, I get access denied. So you can see you have multiple tenants in the same system with their own validated tokens, and the ownership provides a way for you to limit access across those different tenants. Now it is 2:50, so I want to definitely show a few things before moving on, which is the so we showed multi-tenancy here. I want to show you the ability for us to sort of audit this type of information. So one of the things you might be interested in is what happens if your system is trying to be compromised. So say that someone's trying to inject fake authentication through fake tokens, or if a user who doesn't have the right role tries to do something with a volume that they're not allowed to do. What we can do here is, I think I have a number of different examples, is let's just kick off a bunch of them. So let's, as a DBOps user, let's try to inject a fake token, which effectively tries to create a volume with a fake token. So let's create that. Let's create a DBOps user that has view only, meaning that if they're trying to create a volume but only have view permissions or read-only permissions. Let's do those few examples now. So let's head over to our persistent volume claims in the DBOps profile. We have this DBOps 003. You can see that here it says, this was the view only user, right? So permission denied. It doesn't have access to the API based on your role of Open Storage Volume Create, meaning that system.view does not have access to this. So that would be a case where you have tried to create a volume with a user that's authenticated within your OpenShift cluster and authenticated in your Portworx environment, but does not have the right permissions. And it looks like, oh, I created 2 volumes there. So what was that other one? Back to persistent volume claims. Must have been fake token. Well, let's do this. Let's see, create apps, fake token. Maybe I already did create it. I think I did. Already exists. Oh, that's why. Okay. Well, we can delete them. Bingo. And create them. Okay, persistent volume claims. That's for whatever reason it's not popping up, or I'm doing something wrong. But the point is, when you have when you see those roles actually in process, the access control audit logs and the sort of PX security audit logs can be captured. So I have, in this case, we have a a daemon set, I believe, in the kube system namespace that's capturing, which is a FileBeat container daemon set, which has a configuration which actually targets both of these file paths and then offloads them and uploads them to Elasticsearch as a sort of PX audit message. And so when you gather them within Kibana, right, you can start to see things like access denied for volume in this case, right? We can see what's going on. Analytics user was trying to delete the volume ID here, which clearly does not belong to them. So you can get some pretty valuable information. You can also see sort of maybe where some of the hot zones or of the APIs that may be hitting that don't have access to. So I've disabled guest access. So the fact that I'm seeing a lot of guest access denied here is not surprising. But those last few things that we said here, that the system.view user here was trying to create a volume, also has an access denied. So quite valuable information when you're securing your system. And this expands even into PX backup here. And this is a PX backup installation, and wrong password. And PX Backup also now ships with its own security model. So what you can do here is, when you've logged in as an admin, is go into the security PX Backup security interface here, and so you can map users and roles and manage groups such as DBOps, right? So you have a DBOps user within your cluster, and you're enabling self-service for that user to back up their own applications. They shouldn't be allowed to back up other analytics applications. And you can map roles within backup. So are they a backup infrastructure admin, an application admin, or just a user? And these have different methods for actually creating those, and you can add custom roles just like you could within the PX model. One last thing I want to show is that within PX Backup itself, you can federate the users by connecting LDAP. So in this case, I've connected a local LDAP example and imported them directly through Keycloak, which is deployed with PX Backup. And so all of these users here are, some of them are local, some of them are imported into PX Backup and can be then mapped to roles and groups within PX Backup for self-service. So a long-winded way of saying PX Secure enables authentication, authorization, role-based access control with roles, groups, ownership, encryption at rest. PX Secure does things like encryption over the wire for backups as well. And most importantly, enables sort of a self-service multi-tenant model with authorized tokens that can be mapped to users and obviously audited from a perspective. So combine this with the OpenShift security model and add data security for PX Enterprise and PX Backup, and you have a pretty robust capability around securing your data platform within OpenShift. I will stop now for questions. If anybody has questions on the call, please put them in the chat or raise your hand. We can unmute you, whatever you wish.
Hey Ryan, I've got one while we wait here. So the focus here has been OpenShift, but everything you've talked about today, someone listening to this webinar now comes to the webinar in the future, all the Portworx features will work on other Kubernetes distros, right?
Yeah, that's absolutely correct. So PX Secure is a core module for the Portworx Enterprise data platform. So Pxsecure, everything I've shown here today absolutely works on other Kubernetes orchestration systems. OpenShift is just such a good one because they've done, so much with their own system around security that it's a natural fit. But absolutely, whether you're on EKS or rolling your own upstream solution, Pxsecure works in all those cases.
Let's see, any questions from the audience? All right, well, Ryan, thank you for that great demo. Any questions for yourself you want to answer here, or should we we'll call it a day here?
We can call it a day.
All right, thanks, I appreciate it, and please check out our monthly demo next month, coming up in October. And stay tuned, as I said at the front, for more OpenShift content. Ryan's working on some other really cool things, and we'll hopefully get those rolled out in the next few weeks. So stay tuned, and thanks a lot.